In this very lesson, we shall be looking at binomial theorem, which involves fractions. Binomial theorem, which involves what? Fractions. So we'll be looking at questions of this nature. So we realize that all these binomial expressions are in the form of fractions. So before we start with the actual work, let's look at these few concepts in indices. So in indices, when you have, let's say, 1 over x, it can be written as what? X raised to the power negative 1. Similarly, if you have x raised to the power negative 1, it can be written as what? 1 over x. Also, if you have 1 over x raised to the power 2, in indices, we can write it as x raised to the power negative 2. So, if you have 1 over x raised to the power negative 3, it can be written as x raised to the power negative and then negative 3. So at the end, it is going to give you x raised to the power 3. So we are going to base on these concepts under indices to solve questions under binomial theorem, which involves fractions. So let's take our first example. So we have our first example. We have to expand this binomial expression. But I realize that this binomial expression involves what? A fraction. So as I said earlier on, in indices, when you have 1 over x raised to the power 2, you can write it as x raised to the power negative 2. Also, if you have 1 over x raised to the power negative 2, you can write it as x raised to the power negative and then minus 2. And that will give you x raised to the power positive 2. So we are going to apply this concept under indices to expand this binomial theorem. So first of all, we are going to write this in the form of what? This. So we can write this as 1 plus x and then we have minus 4. So we are going to get 1 plus x raised to the power 4. This has become very easy for us to expand. So with this, we can say that our n is equal to 4 and then our x is equal to x. Since the power is positive, we can use the combination or the rational index with the first term being 1. So let's use the combination approach. So we have 1 plus x raised to the power positive 4. So we are going to have, we know that with the combination approach, we have n combination 0, x raised to the power 0, plus n combination 1, x raised to the power 1, plus n combination 2, x raised to the power 2, plus n combination 3, x raised to the power 3. We have n combination 4, x raised to the power 4, and so on. So we know that our n is 4, so we have 4 combination what? 0, x raised to the power 0. We have 4 combination 1, x raised to the power 1. 4 combination 2, x raised to the power 2. 4 combination 3, x raised to the power 3. We have 4 combination 4, x raised to the power 4. Now you know that 4 combination 0 will give you 1. And then any number raised to the power 0 will also give you 1. 1 times 1 will give you 1. So we have plus 4 combination 1 is sure going to give you what? 4. Let's work it manually. 4 combination 1 is the same as what? 4 factorial all over 4 minus 1 all factorial, and then we have 1 factorial. So we have 4 factorial all over 3 factorial. 1 factorial is the same as 1. So this is the same as 4 times 3 factorial all over 3 factorial. So this and that will go. We are left with what? 4. So for combination 1, we have what? 4, and then we have x raised to the power 1. For combination 2 gives you what? 6. and then we have x raised to the power 2. We have 4 combination 3 will give you 4, and then we have x raised to the power 3. And then we have 4 combination 4 will give you 1. Should we work it manually? Let's do that and see. So we have 4 combination 4. We have 4 factorial all over 4 minus 4 all factorial, and then we have 4 factorial. So we have 4 factorial all over 0 factorial, 4 factorial. 0 factorial is the same as 1, or it will give you 1. So we have 4 factorial all over 4 factorial. This will cancel this, we have 1. So 4 combination 4 gives you what? 1. And then we have x raised to the power 4. Let's do our last simplification. So we have 1 plus 4x plus 6x squared plus 4x power 3 plus what? X raised to the power 4. And this is the expanded form of this binomial expression. Very, very easy and simple. The most important thing is you should be able to express this as that so that you apply in solving the question. Let's take our next example. So we have our second example. We have to expand the first 4 terms of the expansion 1 over 2 minus x all raised to the power 3. Now we know that 1 over 2 minus x all raised to the power 3 can be written as what? 2 minus x raised to the power negative 3. So as I said, when you have 1 over x squared, you can write it as what? X raised to the power negative 2. Very, very easy. So we have 2 minus x all raised to the power negative 3. So we have our power to be negative 3. Now we have our first term to be 2. Now we want our first term to be 1 so that we can use the binomial theorem for rational index where the first term is what? 1. We want to use that particular formula or approach. So if that is the case, then we have to massage this expression so that the first term will be 1. So in doing that, we are going to get 2 raised to the power negative 3 raised to the power negative 3. So at this juncture, our first term is what? 1. So we can use the binomial theorem for rational index where the first term is what? 1. So with that, the formula is given as 1 plus x raised to the power n. So we have 1 nx, we have n minus 1 all over 2 factorial, and then x, and so on. So this is the formula that we want to use. That is the reason why we change or we massage this function to get the first term to be 1. So from here, our first term is what? 1. Our second term is what? Or our x is equal to minus x all over 2. And then our n is equal to what? Negative 3. So we are just going to substitute these parameters into this formula. So we have 2 raised to the power negative 3 1 minus x over 2 raised to the power negative 3. So we have 2 raised to the power negative 3, and then we have our macho brackets. So we have our first term to be 1, and then plus our n is what? Our n is minus 3, so we have minus 3, and then our x is what? Our x is minus x all over 2, then we have plus our n is what? Minus 3, and then we have minus 3 minus 1, minus 3 minus 1, we have minus 4 all over what? 2 factorial, and then our x is minus 2 x over 2 raised to the power 2. So we have to obtain the first 4 terms. So we have the first term, second term, we have the third term. So we are left with what? The last term. So we have minus x minus 4, we move to minus 5, and then we have minus x over 2 raised to the power 3. We are to continue, or we can continue, because whenever you have a binomial expression with a negative index, the expansion is an infinite. It doesn't terminate. So we can continue, but our task is to obtain the first 4 terms. So we have 1, 2, 3, 4. Now let's do some algebra here. So we have 2 raised to the power negative 3 will give you 1 over 8. Now this is the same as 1 over 2 raised to the power 3. So we have 1 over 8. And then we have this. So we have 1. So this will give us positive 3x all over what? 2. Negative 4, 3x all over 2. And then we have 2 factorial is the same as what? 2. So you can see that these 2 can cancel for, we have 2. So we have negative, negative will give you positive. So we have positive 6. Then we have x squared all over what? 4. X squared all over 4. And then we have 3 factorial can be written as what? 3 times 2 times 1. So from here we can see that this 3 can cancel this 3. We have 2 into 4, we have 2. So we will be left with negative, negative, positive times negative. We have what? Negative. So we have negative 10. And then this is going to give us negative s cubed all over what? 8. Now from here we can see that 2 can cancel 4, 2, and then it will go into 6, 3. From here, 2 into 8 we have 4, and then 2 into 10 we have 5. So let's write them below. So we have 1 over 8. So we have 1 plus 3x all over 2. And then we have plus 3x squared all over 2 minus what? Minus 5s cubed all over what? 4. So we have minus minus, we have positive. And then we have plus. So we have the final expansion. We have a 1 over 8 outside the bracket, and it is multiplying all those items within the bracket. So we have our final one. So this will give us 1 over 8. This will give us 3x all over what? 16. We also have 3x squared all over what? 16. And then we have 5x cubed all over 32. So this is the expanded form of this binomial expression. So let's take our last example. So we have our last example. We have to obtain the first 3 terms in the expansion of 1 over root of 1 plus 2x. So we have 1 over what? 1 plus 2x. Now we know that the root is the same as what? Is the same as a power of half. So applying the same concept as 1 over x, which can be written as what? X raised to the power negative 1. We can apply the same concept here. If you are having 1 over x raised to the power half, is the same as x raised to the power negative 1 over 2. So we can apply the same concept here. So this binomial expression will be 1 plus 2x all raised to the power negative 1 over 2. So this binomial expression is the same as what this, and this is what we are going to use to expand this binomial expression. So with this, we can observe that our n is equal to what? Minus 1 over 2. Our x is equal to what? 2x. And then our first term is what? 1. So we have to use the binomial theorem for a rational index where the first term is 1. So in doing that, we are going to use this formula. If you have forgotten, let me write it here. 1 plus x raised to the power n. So this is the rational index formula where the first term is 1. So we have 1, and then we have nx, we have n minus 1 all over 2 factorial, and so on. So we are just going to substitute this into the formula. So we have 1 plus 2x raised to the power negative 1 over 2. So we have our first term to be 1. Our n is what? Minus 1 over 2. And then our x is what? 2x. Then we have plus our n is what? Minus 1 over 2. And then we have minus half minus 1 all over what? 2 factorial. We have to obtain the first three terms in the expansion. So we have the first term, the second term, the third term. So we have our x is what? 2x raised to the power 2. So we have 1. This can cancel this. We have minus what? X. So we know that 2 factorial is the same as what? 2. So we can cancel this. So from here we are going to get minus 1 over 2. This is going to give us minus what? 3 over 2 all over what? 2. And then we have 4x squared, and then so on. So let's do some small algebra here. So this is going to give us minus x. Negative times negative will give us positive. So we have positive 3 all over what? 4. And this is over 2. And then we have 4x squared. So you can see that this can cancel this. We have 2. Isn't it? Yes, it is. So we have 1 minus x. And then we have plus. This can also cancel this. We have 2. So we have 3 over 2 x squared. So this is the first three term of the binomial expansion 1 over root of 1 plus 2x. So this is it. This brings us to the end of today's lesson. See you tomorrow. Bye bye.